Okay, so before building the enter your source code or creating the CI/CD pipeline for your source code, it's important to understand your source code folder structure and what files are resides into your source code management. So if you take a look into that, I brought the sample source code which was written in a React, and it contains several directories. So first I will explain you the code related directories, and after that I'll explain you the DevOps or infrastructure related folder structure and files. So here we have the one public directory related to React. So this folder is contain static files, and these static files directly serve to your browser and which are related to index.html and your static images and manifest.json and any other files. So it's this directory has going to be have all your public and static folders which are related and main important to your React application. So if I go to the next directory, which is src, so this where your entire React source code resides, like app.css and .js files where you have written your logic, like what you would like to print on your browser. So here I have mentioned that hi, welcome. This is a simple text, I have mentioned, but if you're working in a real-time project, you may have a number of text or a number of content that would like to bring into your browser. So that's where app.js files, and even if you'd like to test your source code, you can use that app.test.js file to test your source code. And it will have styles like css and crs, and index.js, and so it may have a number of extensions which are more related to your code. And this is the folder is the heart of your project, very important thing where you like to write your content that you would like to print on your browser, and how you'd like to create your application, web application or something. So this is about the src, and the next source code related component file called as nginx configuration file. So this file is more related to configuration of nginx, because we are going to use a docker based image as nginx. That's why I have mentioned the configuration of nginx, which port you would like to use it, and locations of your html files and all. So this is basic information about the configuration of your nginx file. And the next one is the more important package hyphen log.json. So these files, it's going to log the exact version of your every installed package, and every installed version of your source code. It's going to lock it, and it's very important to lock your current version of your entire packages and source code. And the next one is a package hyphen package.json file. So these files contain the entire information, dependencies, versions of your project. So on the other hand, we can say that this is a blueprint of your entire project, like dependencies, script, and dev dependencies and whatnot. So you can keep all your source code informations which you can use to build your project. So this is where it recites all the information like name of it and version, scripts, and browser leads and development. You can keep a number of dependencies related information over here into the package.json, and you can find this package.json file into every React application. And the next one is these all the source code related components. And when it comes to infrastructure or DevOps or DevSecOps related components are Kubernetes and .gitlab-c.yaml file, and always git ignore also, and Docker file. So these all files related to our infrastructure. So far I'll explain you Docker and Kubernetes, and the end I'll go with the GitLab c.yaml file. So this is a Docker file, where we are going to create a image out of it, and because we are going to containerize our application. So this is a very basic Docker file components, which are from the base operating image and work directory, where we are going to keep all our content, where we would like to run our script over there. And we're just copying this the content from our local to the image, and we are exposing our content with the port number 80, and we are going to use the command to uh, run the container. So nginx-g daemon. So this is the command where we can use to run our container. So this is a very basic component. Even it is not much complicated kind of thing, you can easily understand it if you have a minimal information about Docker file components. And the next one in the Kubernetes, so I have written deployment.yaml file and service.yaml file, that I can use this manifest file to expose and deploy my Docker container inside of my Kubernetes cluster into my Kubernetes pod. So the first one is deployment.yaml file. So it's very basic, like a YAML file. I'm using the version of my API, and the object type is deployment. This is the name of my deployment, and very basic information about my replicas of my pod, like what all my label and what all my app label, and very basic things. Sorry, match label and labels of my pod. And this section is related to my container. So what is the container name and where my images resides. So how would like to pull it, and what port do I need to use to expose the particular container. So this is a very basic information about the deployment.yaml file. And the next one is a service.yaml file. Here I have been using API version as v1, similar to the previous one, and the object name is a service, and this is my metadata of my service. This is service name and annotations. And in the under specification, I have mentioned how I would like to expose our service. So here I have exposed as a load balancer, and the selector of my deployment. So this is a selector which is going to take for app, and the port I have used as a TCP, and the expose is 80, and the target port is 80. So it's up to you recommend how would like to expose it based on the protocols, and based on the port number you would like to expose it from internal and external. Okay, so I hope it is make you clear understand about the Kubernetes manifest file, which is very simple. If you have basic knowledge on Kubernetes, you can easily understand it. And now it's time to understand pipeline as a code. So I have written the entire pipeline as a code in .gitlab-c.yaml file into our GitLab CI. So I have followed the best practices of our entire GitLab c.yaml file. So here I have brought the few stages as we already discussed, so for the entire React application build. So these all the stages can be similar to any other application or stack if you're taking, but maybe few stages may get added or maybe removed based on the stack that you are using it. Either it can be interpret language or it can be compile language. So if you see this one, I have the stages called as install, build, test, image build, and image push, deploy, and dash the scan. So as already we have discussed about these all the stages, and what are tools that we are going to use it. And now let's jump into the jobs that are going to use under this stage. So the first job is install dependencies. This job is under install stage, and this is just installing all the dependencies like npm install, and it is going to give a path of it and cache. And this is the job is running on tags called as a CI/CD. And the next one, here we have the another job which is a code build. So we are going to productionize our code. So for that, this job is under build stage, and we're just passing some commands of React. And this is where our build artifact is going to be added, and it will be available over this path. And if you'd like to run this job, so our needs, this there is we have the job dependencies. So if I would like to run this code build, I need to see my pipeline has to be succeeded install dependency, then only it will come for code build. Until unless this job got succeeded, this job won't triggered and this job won't execute it. So that's the beauty of needs. And the next one is tags. Here this job is enter running on CI/CD tag runner. And the next one is unit test. So from here, it is running on the stage called as a test, and this is my job name, and I'm running my unit test with the script. And I'm copying the I'm creating the coverage file over here, icover.info. And this is the need. So again, this is the job dependencies of code build, and I have been using the tags of CICD, my runner tag. And the next one is a sonar check, where I'm going to check the code quality and code coverage. So this is a very basic information about the variables. And here it is the job name, and this is a stage name. And I might have added some sensitive information, but this is not a best practices. So if you're a beginner, so you can use this hard coding into the variable section of your job local. But as for the best practices, you can use Archika Vault or any key vault where you can store your sensitive information and you can retrieve it. And this is the basic catchy path. And here I have been calling all the variables into the script section, and I have been enabling all the sonar scanner is going to be enabled and scan it and push into the respected host URL, and now we can see the report. And if we'd like to run this entire sonar scanner, so I need the job dependency. So unit test job has to be succeeded and executed. And now we have the tag. So this is where we are calling our docker runner, and it get executed. The next we have the job called as a SAST, which is a static application security testing. Here we have been using a Semgrep as a tool, and the job name is Semgrep scan, and this job under the stage of test. And here we have been passing the Semgrep script that it will go and execute towards our source code, and it will file the code vulnerabilities, and it will give the report into the semgrep-result.txt, and you can see the Semgrep result into your web logs also. And this is depends on the Sonar Cloud check job, and for job dependency, and it is running on CICD tag. And the next one, we have the dependency check, where we have, like, using Trivy to scan our source code third party vulnerabilities that we regularly import the open source modules and libraries. So for that, like, we have been um, running Trivy scan to scan our source code. This is the command that we are using, and this is the stage it's under the job, and this is the report will generated if you run our source code. And this is depends on Semgrep scan. So if it Semgrep can succeeded, then it will come for the next stage. And this is the tags of our Docker, yeah, runner of our GitLab. And the next one, I will edit it. So this is just a mistake I have added. So, but yeah, this job, what it will do, it will scan your entire file systems, and it will go and it will find your um, file malwares or malwares or viruses and trojans in your source code. For that, I'm using the ClamAV, and this is a job name, and this is a test under the stage, and this is the artifact path. Once the scanner has succeeded, it will go and publish the report over here, and this is the job dependency of dependency check, and this is the where I'm specify the image tag. This is the very basic things, like, if you're minimal knowledge of DevSecOps, like, what exactly do we need to use it, so you can easily sync up it, even though we have already discussed about all these scans, like, use cases. And now it's time to build the Docker image, since we are containerizing our image. So that's why I have integrated the another job called as image build, and this job is under image build stage, and these are all the variables related to the image of the building. And this is a script, like, I use to build my Docker image, and this is the job dependency, and this is where I have specified the tag of my image. So this is exactly command, like, I used to build the Docker image, and I've just passed it some npm commands for testing purpose, and we can take advantage of this job, and we can create the Docker image out of your Docker file that we have already discussed. So once the image got built, so our responsibility to scan the image and to find the vulnerability. So that's where I have created another job. The job name is image scan, and this is the stage of image build. And this is a script that we are using to scan our images. So currently it is scanning the only one image, but if you have added in stuff here, if you have added dot, it will scan all your images instead of your runner. Or if you'd like to specifically scan the respected tagged image, so you can take advantage of this command. And this is where it is running on the GitLab runner, and this is depend on the image build job. So now one is the, like, image push. Once you have built image, so your responsibility to keep the image secure in somewhere. Whenever you would like to pull the image, you can pull it. So that's where you need to push that image into any image registry. So for that, I have added the image registry job. So here the job name is image push, and this is the stage of image push, and this is the basic variable of my Docker repository. And here I have been passing the script. You may can see the some sensitive information, but it's not recommended to hard code it. Again, you can go with the best practices, but I would like to make more clear and easy understanding, so that's why I kept it as hard coded. And this is where, like, tags of my Docker runner, and this is depends on the image scan job. And now it's time to deploy your image. So since we are using Argo CD, which is continuous deployment and delivery tool, and here we have the job called as a deploy with Argo CD into the Kubernetes cluster. And this is a stage name, and this is the very basic script that we can use as a Argo CD CLI to initiate or interact with the Argo Kubernetes cluster. And here we have the Argo CD login with the URL, and you can this Argo CD has already aligned with the project or application that we have created over here. So this application has already aligned with our Kubernetes cluster, and this Argo CD is running inside of a Kubernetes cluster. So it will go and deploy your all your manifest files, like deployment and service files, into the Kubernetes cluster. So if you see this one, this is the manual, because, like, I would like to do a continuous delivery, and I don't want to automatically deploy it. So that's why I just keep it as a manual. So until and unless I'll go and click the play button, so it won't get deployed. And now it's the tags, like, I have specified the runner tag name, and this is the depend on image push. And the last job is dash the scan, which is dynamic application security testing. So once deployment is done, so I have specified the job name as a dash the scan, and this is the stage of data scan. And This is the script which is executing, and here I have specified my application URL where I have deployed it in the above. So once I have specified this application URL, so what dash scan will do, it will go like here we have used AWS API Zap. So it will go and it will scan towards this IP address, whichever deployment you have done. So if that find any vulnerability, so it will give the report about this path. So you can take this part as HTML. You can see how many vulnerabilities are there in your application which is currently running. And this is the tags of CI/CD, and this is depends on the deploy with Argo CD. So job dependencies are up to you. Like if you'd like to make it, you can create it, or you can go with rules like allow failure true or false. So just to I don't want to do messed up, like if any one job got succeeded or failed, like other jobs to be triggered. So that's why if you have enable a job dependency, so it will go and check the previous job would succeed, then it will get executed with another job. So these all the information about the .gitlab c.yaml file, and I hope you have enjoyed this explanation, and it makes you understand it. So all the source code, what we are exactly using in towards our deployments, and what exactly source code we are using, what exactly our DevOps or DevSecOps files and folders that we are using. So so now we are going to do this entire thing as a like practicalities. We are going to call our each stage by stage, and we execute stage by stage, and we'll do the deployment into the Kubernetes cluster. So now let's discuss about the practical implementation of this entire theoretical discussion.